Algebra 2. Today we're going to begin Unit 2, looking at monomial and polynomials. This is a unit that you had some experience with in Algebra 1. The first part is just on definitions, some vocabulary words that we have to know. First word is monomial. Monomial. And notice the prefix for monomial is mono. That means one. One term that can be, and by term, it can be actually just a number, like 45. It can be a variable, like just y the fourth, or it can be a product of both, number and variable, like negative 12xy squared. All three of these examples are considered monomials. Product, keep that word in mind. If everything I give you is being multiplied together, it doesn't matter how many letters you have, it's still one term. The word polynomial has a prefix of poly. Polynomial means many terms. Many terms. So basically, polynomials are many monomials either added or subtracted together. First example is 24 plus 2x. Well, you should see this is one monomial. This is the second monomial. It is divided in this problem with a plus sign. So there are two terms in this problem, forcing it to be a polynomial. The terms are not like terms, so no, we wouldn't be able to add those together, of course, but that is considered a polynomial. And then notice the last one here, 12 minus 3y plus 5z. I have three terms on the board. They're all separated by minus and plus signs. That's an easy way to tell. There are three terms, and so that's why it is classified as a polynomial. A couple other vocab words. Coefficient, you need to make sure you know from the past. That is a number being multiplied by the variable. It's usually written in front. And so like negative 17x, negative 17 would be the coefficient. Constant is a number that does not have a variable with it. I have 2x plus 8y plus 10. I actually have three terms right now in this problem, so it is a polynomial. Actually, a better word for it would be trinomial. But the term at the end doesn't have a variable attached, so that would be the constant. Using the same example, 2 would be the coefficient of the x term, positive 8 would be the coefficient of the y term, and a positive 10 is the constant. So the first part was just on vocab, making sure you know the difference among those four words. Second part is on monomial rules. There are 5 of these that we're going to look at today and go over some examples together, and then all your practice assignments, there are multiple ones, but all of them that's due for next week are dealing with this topic. The first topic, or first rule, is product rule. Product rule is asking you like what to do when you see monomials, but there's time signs between them. The rule is very simple and straightforward. You just have to make sure you get it in your head. You are supposed to multiply coefficients first, and when you do that, then you're going to add the powers on the same variable. Multiply coefficients and add powers. Alright, so for the first example, I have y to the fourth times y to the fifth times y to the 12th. Notice that I have three monomials on the board, and they all are being multiplied. Okay? Your job is to simplify the question. And so based on the rule, I'm supposed to multiply coefficients. I don't see a number in front, so it's an understood 1. And so using this part first, I would multiply 1 times 1 times 1 and drop my answer down. Easy enough. Then I would add the powers as long as it's the same letter. You can see that I've used the same variable. So I'm going to drop my y down, and then I'm going to add 4 plus 5, which is 9, and 9 plus 12, which is 21. And so the answer to this problem is y to the 21st power. Okay, number 2, I have a monomial here in the first parentheses. This is considered one term, even though it does have a coefficient and two variables. Notice that it's all being multiplied together. This is also considered one term. Everything's being multiplied together. The parentheses indicate that I'm supposed to multiply this monomial times this one. We're going to multiply coefficients first, negative 4 times 12. We're going to look at x's next. There's 3 here and there's 8 here. We're multiplying them, but the rule for powers is adding, actually. So the rules for exponents are different. You're just going to drop your x down. You're going to add 3 plus 8 to get 11. Then you're going to look for your y term. I have 6 of them in the first parentheses and 11 in the second. So total, 6 plus 11, I have 17. In the first monomial, I do not see a z. In the second one, I actually do, but we're just multiplying these, so we have to drop it down. And so the answer to this problem would be negative 48 x to the 11th, y to the 17th, z. Okay, so that's very simply how you would approach the product rule on those problems. Should be easy. Very straightforward. Okay, number 2 is called the power rule. Power rule is easy to notice. You're going to look for basically powers that are outside parentheses. You're going to multiply that power outside parentheses by all the powers on the inside. Power rule is a shortcut version of the product rule. So I'll show you what I mean in just a second. Again, power rule is the shortcut version of the product rule. And so I'll show this in example 1 based on that statement to make sure you are with me and understood what I said. So let's say we have x to the 5th raised to the 4th. And some people like to think of this like, well, that's one term, it's raised to the 4th power. So based on exponents from the past, that just means to write down the base, which is x to the 5th, 4 times. Now this is a little bit longer, but I want to make sure that you see this in your head. So technically you are allowed to do this if you want to. So whatever this is, write it out that many times. So what I've basically done is took a power problem and turned it into a product problem. Notice my example up here, this looks very similar to this one now. And so I'm just going to follow the same rule as above. I'm going to multiply all the coefficients together. 1 times 1 times 1 times 1. Got it? I'm going to drop my letter down, and then I'm going to add my powers. 5 plus 5 is 10, plus 5 more is 15, plus 5 more is 20. So the answer to this problem is x to the 20th. And again, what I've just modeled to you is me taking this problem and turning it into more of a product rule problem, and it works that way. Alright, now let me show you why I said power rule is a shortcut for product. I'm going to copy the same problem down, the original problem, and I'm going to refer back to my power rule. It says I'm allowed to multiply the power outside parentheses by everything on the inside. So I see 4 here, and 4 times 5 is 20, and just like that, with no work involved, I got my answer. And so, again, that's why power rule is faster. But I would like you to know both, like be able to see both of them in your head. Okay, so from here on out, number 2 and 3, I'm just going to stick with the power rule. And I'm going to notice that in this example 2, I have a negative 4, a to the 3rd, b to the 7th, c, but there's a big power of 2 on the outside. I'm supposed to take the 2 and multiply it again by every power I see on the inside. Make sure you are watching carefully and listening, because this is a common mistake. Sometimes, like we can see there's a 3 on the A and a 7 on the B, but we don't necessarily see a power on C. That does not mean there isn't one. C is actually raised to the 1st power, so you need to make sure you put that in there. Also, numbers, like the coefficient here, that has a power as well. Again, we normally don't write it this way, but negative 4 is the same thing as negative 4 to the 1st. So basically, every time you see a power rule, make sure every piece has a power on it before you start multiplying. So you're going to multiply the 2 times the 1, and times the 7, and times the 3, and times the 1. Okay? Also, it's a good time to mention this. When you are doing a power rule, if this number, the leading number, is negative, you really have to use parentheses around this number. If you forget to do that, you're going to type it in your calculator, unless you're doing it in your head. But if you're typing in your calculator, calculator will give you the wrong answer. So you do have to put it in parentheses. -4 to the 1 times 2, and we'll just jot down 2. Then you're going to look at your A. You're going to drop your base down. Drop your A down. You're going to multiply 3 times 2 and get 6. You're then going to bring your B down. You're going to multiply 7 times 2 and get 14. You're going to drop your C down. You're going to multiply 1 times 2 and get 2. Okay, and then the last thing we need to do is just simplify this piece. And so if you'll take your calculator and literally use parentheses around -4, and then I actually want you to type it in without parentheses. Just type in -4 squared. Take a second and do that. And so that way you can see the point I was trying to get across. You can see the difference. Okay, if you've done that, then -4 with parentheses around it actually gives you positive 16. But if you type it in without parentheses, the calculator says -16. That's the reason it's super important to use parentheses. So we're going to use a positive 16 here and then bring down everything else. Okay, so my answer is 16, A the 6th, B the 14th, and C the 2nd. Example 3. This time I want you to notice that I have a monomial here in the first parentheses, but there is a power on the outside. And then I want you to notice I have a second monomial, but there's not a power on the outside. Well, technically there's a 1 there, but me putting a 1 here and multiplying it by all these powers is really not going to change anything. When you multiply by 1, it's the same value. So if it's 1, I tend to not write it here. But this problem is a combination of these two rules. It has a product rule, and it has a power rule. And you're always going to follow PEMDAS in that order, so you know, or do it in that order so you know you're going to get the right answer. In other words, always do exponents or powers before you multiply. So that means I need to take care of this 3 first, and I need to multiply it by all the powers I see. And again, second time today, make sure you put the 1 above the number, because numbers have powers as well. Okay, I'm going to drop my parentheses down in my -5. I'm going to enclose that with a 1 times 3. So I'm going to write it like this. Then I'm going to drop my G down. Then I'm going to multiply 3 times 3 and get a 9. Then I'm going to bring my H down, and that's going to be 9 times 3, which is 27. And then I'm just going to put parentheses around all of this right now, just to kind of keep it separated and organized. Then I'm going to drop my second monomial down, as is. Okay, so all I've done is the power rule. Alright, next I want you to notice, before we multiply these, I still have a power in my problem on a number, and we know how to simplify that. So we're going to write this as -5 times, like in our head, -5 times -5 times -5. We're going to evaluate that. You can use your calculator. Again, please use parentheses around the -5 when you're typing that in. This answer is going to give you a -125. You're going to bring down your G to the 9th and H to the 27th. Okay, now we're ready to multiply. We are multiplying monomials together, so we're multiplying -125 times 11 And that should give us a negative 1,375. And then we're going to go with the G's. This one has 9 and this one has 1, so we're going to combine them. Remember, you're adding powers in the product rule. So that's just going to be G to the 10th. And you'll drop your next letter down, which is an H. There's 27 of them here, and there's 8 here. And then so 27 plus 8 becomes 35. Okay, and so that is your answer for that problem. Again, when you have two rules in one, always follow PEMDAS. Always do power before you do product. Third rule today is quotient rule. Quotient rule, quotient means divide. So in other words, if I see a monomial divided by a monomial, the rule says for me to divide the coefficients and subtract the powers as long as it's the same variable, same base. Example 1, 34 x to the 12th y to the 9th divided by negative 2 x to the 4th y to the 7th. Okay, notice there's no parentheses, so I don't have a power rule. Also notice there's no time signs here, like monomials that need to be multiplied together. I do see a quotient, a big division bar, so I'm going to apply this rule as is. I'm going to divide the coefficients. Divide 34 by negative 2. And drop down your answer. It's as simple as that. Then we're going to go with the variables, and we're going to subtract the powers. The top one has 12, and the bottom has 4. So when I put those together with a quotient, that's 12 minus 4, and so that's going to be x to the 8th. Then I'm going to drop my y term down, and I'm going to do 9 minus 7, and that's going to be 2. And just like that, there's my answer. Okay, look at number 2. Number 2 has a monomial in parentheses, negative 6a squared b to the 6th, but there is a big power 2 on the outside. So this one is a power rule problem. Again, before you forget, make sure you put a little 1 there. So I've got a power rule on top. I've got a division bar, so I know I've got to use the quotient rule, and that's all I see. So decision time, what do I do first? Again, always do power rule first when faced with this scenario. So you're going to simplify the top. You're going to drop down your negative 6 in parentheses. You're going to say 1 times 2 is 2. Drop your a down. 2 times 2. Drop your b down. And 6 times 2. Alright, and then you're going to go to the bottom and recopy your monomial. Since this one does not have a power on the outside, then I'm allowed to just leave it like that. Okay? And then in the numerator, we'll go back, and I've got to simplify this. So using parentheses in your calculator, if you need to, you're going to type in parentheses negative 6, close your quantity parentheses squared, and that's going to give you a positive 36. Copy everything down, and then to finalize this, you're going to need to do the quotient rule. And so again, the quotient rule says coefficients need to be divided. 36 divided by 4. 4 goes into 36 9 times. A to the 4th divided by a to the 1st. We are to subtract powers when we're dividing. Subtract powers. 4 minus 1. Then we deal with the b's. Top one has 12, bottom 5. 12 minus 5 to get 7. And so that required a little bit more work. You do show all your steps. That's your answer. Alright, next, negative power rule. The negative power rule, if I have an exponent that has a negative on it, then we cannot leave that in our final answer. Cannot. And so your job is to take the term that's raised to a negative power. When a term is raised to a negative power, you are to change the position of the term. And basically I just mean move it. So if it's on the top to begin with, I need you to move it the whole term to the bottom of the fraction. And that also works the other way, vice versa. But when you do move a term that has a negative power, then the negative power actually goes away. It changes to a positive, and then your answer is more simplified. Again, do not leave negative exponents in your final answer. Okay, take a look at number 1. I have x to the negative 5 times y to the second. And so this one is obviously negative. 2 is not. So what I'm going to have to do is create a fraction so I actually can move it to the bottom. I'm going to take this part of the term, because that's a single monomial, but I'm going to take that to the bottom of the fraction bar or division bar, whichever way you want to say it. They're both the same. And when I move the sign changes back to a positive. And then this one is already positive 2, so it's going to stay where it is, and basically it's going to stay on top of your fraction. And so that is your final answer. That's so much better than the original problem. It also works with numbers. Check out number 2. I've got 7 to the negative first. I cannot leave that as it is, so I'm going to have to take this entire term to the bottom. The negative 1 becomes positive 1. Now this is interesting because I don't have a letter with it or anything else multiplied by this. So when that happens, you have to put something there. It looks odd if you don't. So you're going to put a 1 as a placeholder. And so basically the answer to this is just 1/7. I'm going to take off the power of 1 because we normally don't write it if we're trying to just answer the question. And so it's 1/7. Alright, check out example 3. I have a 64a to the 4th b to the 9th c. That is one monomial. And it's being divided by one monomial, which is negative 4a b to the 12th c to the 3rd. So I don't see parentheses, I don't see a power rule, I don't see a time sign for me to multiply. I do see a quotient. And so I want to go with quotient first. I'm going to divide these coefficients. 64 divided by negative 4 is negative 16. And then I'm going to drop my a down. And I'm going to subtract 4 minus 1 to get 3. I'm then going to focus on my b's. I have 9 and then a 12. So I'm doing like 9 minus 12. 9 minus 12 is negative 3. Then I focus on my c's. And this is a 1. I do 1 minus 3. 1 minus 3 is negative 2. So I'm going to put that right here. Okay, so now this appears to be the answer, but I just told you that we need to make sure we never leave negative powers in our answer. It is okay to leave a negative as a coefficient because we work with negative numbers every day. We just don't want negative powers left. And so here's how you handle that. You're going to draw your division bar to create the fraction again. Notice that negative 16 actually has a positive 1 power on it, so it's going to stay on top where it is. I like the a as well because it's positive 3, so it's going to stay on top. And the b has a negative power, so it's going to be moved to the bottom, change the position of it, and when I move it, it becomes a positive 3. Likewise, c is doing the same thing. It's a negative 2. We want to move it and make it a positive, so we're going to call it b to the 3rd, c to the 2nd on the bottom. And that is your best answer. Alright, last rule for today is the zero power rule. If a term is raised to the 0 power, the answer is always 1. Always. That one's the easy rule. And so I don't care if the 0 is on a number or a letter or a whole part to a problem, that part of the problem is 1. So look at number 1's example. I've got 45 to the 0 power. That basically tells me exactly what to do. I write down my answer, I move on. 45 to the 0 power is 1. You also can take a second and check that out in your calculator, because that's one of those rules that students just have to kind of memorize and know, but you always can calculate it on your calculator to double check. And if you type that in, 45 to the 0 power, it should give you a 1. Example 2 says 12x to the 0, y to the 7th. I see a 0 power there. So I'm going to drop my 12 down because the 12 doesn't have a 0 power. This piece does. So technically the x to the 0 is the only part that changes to 1. And then I drop my y to the 7th down. So you've got to be careful where it's placed in your problem. If it's in the middle, you go ahead and bring down the rest of your pieces to your answer. And so 12 times 1 is 12. 12 y to the 7th would be the best choice. And then finally, check out number 3. I've got a monomial in parentheses with a big power on the outside. I can do the power rule if I want to. I can call this negative 4 to the 1 times 0, a to the 1 times 0, b to the 1 times 0. I can go through that step, or I can just look at it and say, well, the 0 power rule says anything raised to the 0 power is 1, so that entire piece is just 1. That's the fastest way. And then drop down your 5a, because notice the 5 is not, or the 5a is not raised to the 0 power. And so technically you do have to drop it down. And so this answer would be 5a. So again, just pay attention to where the power of 0 is placed in your problem. I don't want you to get it in your head that every single time you see a power of 0, the entire answer is 1. It just happens, it depends on where it's placed, as I said before. So in this section so far, we've dealt with product, power, quotient, negative power, and 0. And then you're going to take the next couple classes and just focus on making sure you understand those rules and you can apply them to all kinds of different types of problems.